Hey Dr. Salim, it's me. Just providing you with a video update to go along with the pictures that I'm sending you. So here's what I got so far. Alright, this is what you saw last time. This is my 12 volt DC battery, which is run to this inverter, which inverts to 230 volts single phase AC, which is what this needs to power. This is the variable frequency drive. It's basically a large microprocessor that controls everything that goes on in my system. And right now it's set to operate in digital display mode, where you can set the frequency using the arrows to run the motor at the given speed. Well, I don't want that. I kind of want to mimic a vehicle, so I'm using a little foot pedal rig. And what this is a 5K potentiometer. And the pedal is actually attached to the dial of the potentiometer right there, so that when it's pressed, it will increase the voltage. And this runs between 0 to 12 volts. That's being supplied by the box. So, obviously, I want it to read the signals from the pedal and not the box, so I need to program this to do so. This is handled by constant number 1. Now, each of these numbers represent something different, and each can be set from 0 to 0 or 1. These last three are the only ones that concern me. This first one is what tells the motor how to stop, whether it's automatic and it's assisted by the box, which is 0, or it just coasts to a stop. And since I'm doing regenerative braking, I want it set to coasting, which is the 1. This one lets the box know where it's receiving its signals to tell the motor to run in either forward or reverse. There are little LEDs here, and if I was supplying them manually, these would be lit up, but I'm not. I'm having the box supply those. What I am supplying manually is the reference frequency, or the reference voltage that comes in, and I'm doing that by using the potentiometer. So, right now, a 1 means that it's using the digital display. Well, no, I'm supplying them manually, so I'm going to set it to a 0. As you can see, that little reference light says REF pops on, lets it know it's going to be receiving its reference frequency from somewhere else. So, let me just enter that again just to be sure. Now when I run back in drive mode, you can see that the frequency it's reading right now is 0, because my pedal's in the off position. But when I push it, I'm pushing the pedal down now slowly, it increases the frequency. Now, this motor is set to operate a maximum at 60 Hertz. As you can see, I've got the pedal all the way pressed down, and it's only reading up to about 26 Hertz. Well, that's because of two other constants that I can set, namely the bias and the gain. First is the gain, constant 22, and the box does not let me set this value higher than 2, so I'm kind of limited. If I wanted the pedal to go from 0 to 60 Hertz, I calculated it, I would need a gain of about 6.6, 6.7, something like that. Unfortunately, the box only lets me set this to 2 maximum, and so I set it there because I want the greatest range possible. These two constants are responsible for the box even recognizing that this is attached and will be controlling the frequency. These set the range at which, this is the other constant. Anyway, what I was saying is that these two constants are responsible for setting the range at which this pedal operates, because I have this, even though this can turn 270 degrees, I have it limited to only about 45 degrees. And what this means is that the potentiometer only allows from 0 to about 2 volts to run through. So I need to scale the box and let it know that at 2 volts I want it operating at its maximum possible frequency. And again, I could only get up to 26, even though I wanted to go to 60 because of the gain limitation. And then here's the other piece of that. This is constant number 23. This one determines what percentage of 60 hertz I want to be applied when my pedal is in the 0 volt position or off. So right now I have it set to 0 because I want the motor to be stopped until you push the pedal in. Just to show you as an example, if I wanted 10% of the frequency to be applied to the motor when my pedal is not pressed, I just enter 10%, go back into drive mode, and as you can see, my pedal's off, but my frequency is initially at 6, 10% of 60. So, but I don't want that. I want to start from a stopped position, so I would like 0% of 60 volts. Okay, and so that's the pedal part. That's how the box receives the signal from the pedal to tell the motor at which speed to run. Okay, well, the other part of this project is regenerative braking, and that little system is right here. This is an old bike dynamo. Used to be used to run against the tires to power the little light that goes on the front or back. And I'm using it to show how regenerative braking works. If you can imagine this little spring switch to be your brake, when you lift off your accelerator, move your foot over to the brake and press it, this snaps against my wheel, which will be turning, and as it coasts to a stop, it turns this, which is a little 6-volt DC generator. And so that creates 6 volts. Well, the generator turns, and it generates DC voltage to run through here. And in order to get into my batteries, I have it running through this circuit board that came from a cell phone charger. Because cell phone chargers are already designed to run from DC generation, namely your car's battery, into a device you have in your car. And so I have these batteries that I took out of a 14.4 volt battery pack. There were 12 cells in there, and I only have 3. So I'd imagine that each are about 1.2 volts, giving me a total of 3.6 volts across this series circuit. Well, series load. Well, as you can see, I've kept the generator attached to the batteries, completing the circuit, so it's just kind of been bleeding the voltage down. So it's really low because I'm going to demonstrate that as your car is running, here I go pressing the pedal. Okay, frequency is running. Oh, I guess I actually have to set it to run mode. Okay, so now as I press down the pedal, you'll be able to hear the motor turn on. There it is. Okay, it's running slow right now. There's my wheel turning. And as I continue to press on the pedal, it increases the frequency until I get to my maximum of 26, about. So now this is running at 26 hertz. Well, in order to show you the braking, I'm going to leave the wheel running, so I'm not actually going to let it coast because there's enough friction created in between here that it stops the wheel pretty fast. So I'm just going to leave it running just to show you how this works. So let me go ahead and hit the switch. It is snapped against there, and as you can see, the generator is now spinning. And if you look at the voltmeter, voltage is increasing in the batteries. Where it was at 1.16 or whatever, I can't remember now, it's now increasing. There you go. And so that's how regenerative braking works. It takes the energy from your wheel and runs it into batteries, whether that's the same battery that's supplying the power to your whole system, or a separate battery pack that you could use for storage at a later date. As you can see, the voltage is going right up there. I was measuring this before. This was actually getting up to around 4 volts, which is a little greater than the 3.6 that I'd imagine comes from these cells. So that's pretty awesome. The other important thing is this circuit board is important because it determines when these are fully charged, so that it stops the flow of voltage from the generator into the battery, so that it prevents overcharging. So that's the other key factor that this circuit board plays. Anyway, that's about it. As you can see, actually here, let me turn the light off real quick so you can see that as the dynamo runs, this light lights up to let you know power is running through into the batteries. Off, light is off, on, light kicks on. Sorry, I know it's a little blurry, but it's the red blur. So anyway, that's pretty much how all that works. So just let me know if what the best way to proceed is, and I'll do it. Or if you have any questions. Alright, well, I'll talk to you later. Thanks. Bye.